Doctor has ordered 300 milligrams of a drug. So this is what the patient will need to receive. This is what we want to give to our patient. Then we read on and we see 200 milligram tablets are supplied. So this is what we have in stock. And we could interpret that as 200 milligrams per each one tablet. Each tablet contains 200 milligrams. So we need to find the quantity of tablets required for this patient. Is this a ratio box problem? Yes. We have this pink ratio, two quantities connected as a ratio, and we have the third quantity, the blue 300 milligrams, that actually matches with one of those in the ratio. So we draw the box, and as I said, no need to use a ruler, just a simple box with 4 spaces. We start with the ratio every time, put the ratio into the box, 200 milligrams over 1 tablet, just like a fraction. Make sure you do use the units, you attach the units to each quantity so you know what they mean. 200 doesn't mean anything. 200 milligrams does mean the quantity of drug. So those two are already in. We don't need to worry about them. The only quantity left now is the 300 milligrams. We need to be careful to place it exactly in the right position. So it needs to sit on the top because the milligrams must match. So that one is done as well. All we need to do now is do the calculation. So now we have been doing this in our heads because we had very good, comfortable numbers to work with. But this time, 200 into 300 is not really doubled. It's not tripled. So that means it might be, you might be able to do in your head and think, hey, it's probably 200. It's the same 200. It's not twice, but it might be 300 is 200 and another 100. And 100 is half of 200. So maybe we could say this is times 1.5. But if we thought, no, don't want to do it that way, I'll do the full calculation. But that is why we have the box. So we will look at the diagonal that has the two quantities and we'll multiply those two. So 1 tablet times 300 milligrams divided by 200 milligrams. Again, here we can cancel some zeros off, divide by 10, which means simply cancel zeros off. Then we have 1 times 30 over 20, and we do the cancelling again, divide by 10 and divide by 10. So we are always crossing zeros off when we can divide the two quantities by 10. So what do we have? 1 times 3 divided by 2. 1 times 3 is 3. 3 divided by 2. Well, you probably know that in your head, but if you had a more complex calculation, you could even do the full division. 3 divided by 2. That's the end of the whole number here. So we ask ourselves, how many 2's go into 3? 1. 1, 2 is 2. 3 minus 2 leaves us with 1. We add a 0 to carry on with the division. 2 into 10 goes 5 times exactly, so 1.5. We go back to the box to see what our question mark meant. It meant tablets. So 1.5 tablets, which probably reads better if we write 1.5 tablets, because 0.5 is the same as half. Can we give this quantity? Yes, if the tablets are scored, and we can exactly break them in 2 halves. So we're going to give 1 full tablet and half of another tablet.